This webcast talks about a rate discovery mechanism done for the US freight industry totaled $1.45 trillion, which represented 8.3% of the total GDP. The industry uses different modes of transport, including air, ocean, rail, and road. Of the total freight tonnage across all the models, nearly 70% is transported using the roads. The industry comprises of carriers that carry the commodities for shippers using a commercial vehicle. Major services in the trucking industry include long distance and the local trucking. Within the long distance, 80% of the revenue comes from general merchandise and the rest 20 is from movement of special goods like chemicals, autos, oversized or fragile goods. In the local shipping market, general merchandise accounts for 40% of the revenue, whereas specialized trucking accounts for over 60%. Now, the type of operation that a trucker runs depends on the type of shipments handled. Some handle only truckload shipments that dedicate trailers to a single shipper's cargo. Others specialize in less than truckload, which transport the consolidated cargo of several shippers on one truck, dropping goods at multiple delivery points. Now, one of the major problems faced by the trucking industry in the US is the increasing transportation cost due to driver shortages, rising insurance costs, and fuel price variability. Hence, it is highly likely for the carrier to charge a higher premium for the shipment to make up for these rising costs. But at the same time, an individual shipper must not be fooled by these high premiums. He must be able to negotiate competitive rates with the carrier based on the current market rates. This is where the rate discovery mechanism comes as an elixir to the shipper's predicament. So, how does the rate discovery mechanism help them? The rate discovery mechanism considers the shipper's transactions and predicts what should be the cost of each transaction based on the performance of the market. It helps the shipper understand what they must pay for a particular type of shipment. How much should they be paying if their load is going to a particular state? At the same time, it also helps the shippers analyze their performance across each lane so that they can make correction measures for the poor performing ones. Moving on to the process. A standard data template is prepared which captures most of the data pertaining to the shipments. An individual shipper who has entered into an agreement with the consultancy is then contacted to share their TMS data. Once the data from all the shippers is received, it goes through the conventional CRISP DM cycle. The first step is data preparation, which involves converting the individual shipper's data to the standard template, which ensures consistency. The data preparation also involves a data validation, where major issues regarding the data are reported. After necessary discussions, decision is made regarding the errors and outliers based on which the data preparation step is completed. The cleansed data is then prepared for modeling, which includes creation of flags and dummy variables. One major step in this process is to create additional variables for the origin-destination state pairs and append that to the current data. This is called the influence matrix. The influence matrix is a binomial or smooth matrix which captures the influence on the cost if a particular shipment is going from one particular location to the other. For instance, the shipment moving from California to New York is likely to be cheaper than a shipment made from New York to California because California is primarily a production center, whereas New York is a consumer area. Once this process is complete, the data is then fed for modeling. As a preliminary step in modeling, the entire data is then split into subsets based on the length of shipment and the mode of the shipment. Any shipment greater than 250 miles classifies as a long haul, and that less than 250 miles as a short haul. The different modes of shipment include dry van, temperature controlled, flatbed, and intermodal. Hence, combining these two cases, we have 7 models, namely the long haul dry van, short haul dry van, long haul temperature controlled, short haul temperature controlled, long haul flatbed, short haul flatbed, and the long haul intermodal. Intermodal shipments are made only when the distance is greater than 500 miles, thus there would not be a short haul intermodal model. The attributes influencing the individual models mentioned above are then identified and a regression model is developed which then predicts the cost for each transaction for each of the model based on the characteristics of the shipment. The predicted cost is then aggregated across various parameters like carrier, lane to give insights about the shipper's market performance. The model is tested against standard test data for validation purposes. Results and outcomes. Once the modeling is complete, the Tableau dashboards are generated for lane and carrier results. The lane results helps the shipper identify his poor performing lanes and take steps to improve his rate negotiation on that lane in the subsequent procurement bids. So, what are the challenges for this rate discovery mechanism? The rate discovery mechanism is an enabler that helps the shippers make fact-based decisions across their supply chain. It also helps the shipper have a better understanding of the freight market and thereby help in improving the decision making. Some of the challenges, however, during the process include handling the uncertainties of the dynamics of the freight market, such as weather and the labor issues. Additionally, fuel variability is another challenge in the rate discovery. The prices of the fuel are too hard to predict, which affects the rate discovery mechanism. Despite these challenges, the rate discovery mechanism does a decent job in accurately predicting the cost for each transaction, which helps in making fact-based decisions for the shipper. Thank you.